So our next speaker is Jörg Urban. Jörg is from ADVA, and he's going to talk about something very topical, which is, the timing of 5G, aligning again, I think, back to what Brian Armstrong said this morning. Jörg, thank you very much.
Thank you. I think now I'm on.
You go.
Okay. Yeah, hello to everyone. My name is Jörg Urban. At ADVA, I'm responsible for the business development of the timing and synchronization portfolio for the EMEA region. The topic for today is, let me just go on here. There's one slide missing, but anyways. So the topic for today is get your timing right for the 5G O-RAN. And now I need to think about it. So for 5G O-RAN, I think what we're experiencing out with the mobile operators is that this topic is something moving from important to critical. Now, why is it? There's one fundamental thing which we need to understand, and this is if we don't get the timing right in the 5G mobile backhaul, then we will have see an impact on the 5G spectrum utilization. So the well-designed timing infrastructure in your mobile backhaul will guarantee at the end of the day a full spectrum utilization and the investment actually you have been taken to acquire the frequencies. There's also an interesting survey done by Heavy Reading, which I will show later on, which ranks actually also this topic as very important. But before we going now into the details, here the agenda, I would like to give you first an overview about what actually ADVA is proposing when it comes to an open mobile backhaul architecture. What are our technologies we can offer here? And also how timing or timing capabilities have been moved across the product portfolios into the various technologies. So that's also very interesting to see. Next is then that we want to have a closer look into what are the timing requirements for 5G to work. Then we will look about the source for time, GNSS. I don't know if you know this term. GNSS is the Global Navigation Satellite Systems. We have up in orbit, they providing us with so-called PNT services, position, navigation, and time. We use time for our products, for our timing servers, and with this we can actually then enable a time sync architecture towards the 5G remote radio units. So we'll see what are the pros and cons in one way or another. We're implementing or using the GNSS antennas to time sync the 5G remote radio units. And then from that, while we understand a bit how to use, what are the deficiencies or the benefits and advantages, we come to the last part where I want to explain to you what can be really a blueprint, what can be really a resilient end-to-end time sync architecture solution for the mobile backhaul network. This shows now the four product portfolios ADVA is currently developing. So there is the optical transport here. Also, during the evolution is also towards openness and disaggregation. The packet-based technology, layer 2 with some layer 3 enhancements, also disaggregated open platforms in order to support NFV, SDN type of capabilities, and then network synchronization that came into the portfolio with an acquisition back in 2014. Since then, we have developed and enhanced this product portfolio with new products, with new features, now really ready for out there deployments in mobile operators. For 5G, we know it's important to have good fiber infrastructure to get it well working, and across the whole architecture, whole mobile backhaul architecture, there is also good to have an active line monitoring system to monitor actually your fiber assets. So how will that look like high level as an open network architecture? We see from the right, the older timing servers, then connected towards a core metro DWDM network. It's our FSP 3000 series, which fits here in the core metro. And what you see here already, that we have enabled this platform to carry actually the timing information from the source further out into the access of the network. That is new technology. ADVA was a bit first to this, and we see also now slowly that other DWDM vendor following the same approach here, because it's essential to show that the products are becoming time aware in order to build the new 5G open network architecture. Going forward, also the packet-based products are being enabled, being now time aware. It's important. I don't want to go into the details what that technically means, but in order to support now this end-to-end from a source to the destination where we have the remote radio units, all the elements in between need to be enabled. And the complexity with Open RAN is of course increasing. That's maybe the flip side of getting the openness, but it's of course doable. Across all the products, we of course have the management system, a sample controller. Some of you may use it in order to have an end-to-end view from the communication, also from the time sync services you're providing across this architecture. So the survey I promised you already earlier, this is done by the Heavy Reading in 2020, and they wanted to understand what are the most important technologies or protocols when they consider 5G and a re-engineering of the mobile backhaul. And they said that the network synchronization protocol is the most important for them. My interpretation about this is that to some extent this technology is not so much known in the organization as it is maybe to design or engineer a MPLS, a carrier Ethernet network, and so on, or DWDM network. This is fairly new technology, a new topic, but it needs to be taken on and need to be resolved. And as I said at the beginning, if we get the timing right, then we have also a well-functioning 5G network, radio access network. Okay, what are the requirements when it comes to 5G? Get more details on this part of the thing. We have a change from 4G to 5G in the way we operate the radio and the up and down links on the radio side. With LTE, we used to do FTD, so frequency duplex, and that means we had the frequency for the uplink and the frequency for the downlink. Now with 5G, we use TDD, which means time division duplex. So the uplink and the downlink are running on the same frequency, but we're using different time slots for the uplink and the downlink. So if we're not getting it accurate in terms of timing, the 3GPP defines 1.1 microsecond accuracy traceable to a reference, which is UTC. So then you have a problem on the radio side. The radio will not work in an efficient way you would like to see that. So this is one of the key criteria to get sorted. We can go now into different 5G radio applications. Then you will see that there are even more stringent timing requirement going into the sub-microsecond region, and that is something to look at as well, while we certainly want to use other radio access technologies than just a simple TDT communication with the end device, for example, carrier aggregation or a massive MIMO. While we have at some point the 5G radio access deployed and running, looking forward into the future, we may see also applications and services you want to introduce on top of the platform. Private 5G was mentioned, but also the other services to support smart cities, smart grids. And then you will realize that also this application layer will need accurate timing to work. And so this is also what has been specified now recently with 3GPP release 18. So they specifying how timing can actually be transmitted across the radio link towards the end devices. This can be an IoT, which you want to get some data from. You also want to understand where this piece is somewhere in the company, and somewhere in a larger facility. So you need to understand that that requires some special mechanism in order to work. And that maybe involves also the mobile edge. So if you have a small piece like this, then you need to think about, okay, how do I get enough power into it and a GNSS receiver into it to understand via GNSS where this piece is actually located. But you can go a different way using 5G and the mobile edge application to analyze, to compute actually the position of this specific device. So certainly a number of aspects need to be considered. Another aspect with regards to this is if you're not delivering the accuracy as required, 1.1 microsecond, your antenna starts to interfere, to generate interferences. These interferences will impact negatively your own installation, 5G antenna installation. It will also impact other mobile operators' antennas, and that is something then potentially for the regulator to see what kind of measures need to be taken to overcome this situation. So a lot of things depending on if or whether you're not getting the timing right in your network. So let's look a bit at the GNSS, the global navigation satellite system we have in orbit. We use it everywhere in our car, for example, to navigate through a city. And we expect it will work everywhere at every time. But this is not the case. It is free, but it's not a reliable system. And that is why we need to have a backup. So let's look at why this is not a reliable system. And this is because it's highly exposed to cyber attacks. There are two listed, which is jamming and spoofing, whereby jamming is by far the most easiest one. You just use a strong transmitter, which actually destroys all the signal in a great area, in a large area, or in a small area, depending on how strong your transmitter is. And the GNSS antennas will not be able to receive and to understand any of the signal which coming from the satellites. So this is really absolutely key thing to understand, because this is a big threat to your whole 5G antenna installation. And it can really impact your services which you want to enable across this, over this 5G antenna systems. So something really to look at seriously. We're also experiencing other outages while we look at the GNSS system in general. This can be GNSS outages, for example, but also solar activities impacting the use of the GNSS as a source for time. So all these together requires something to mitigate these vulnerabilities, and that can be somehow presented or solved by a new end-to-end time sync architecture, and that is what's being shown here. it's a high-level depiction, but what I would say is already implemented in a number of networks, actually. And ITU has specified new systems called EPRTCs. These stands for Enhanced Primary Reference Time Clocks. They come with a certain accuracy, and the system is being built out of essentially 3 components: a timing server, a cesium clock, and a GNSS receiver. And this guarantees plus minus 30 nanosecond traceable to UTC, so highly accurate time source, and also a highly secure time source when it comes to these potential GNSS outages or cyber attacks. So it can maintain this 30 nanosecond for a couple of days or even weeks. So this makes your installation quite agnostic against any of these GNSS vulnerabilities or cyber attacks. And that is systems which are being deployed already now in networks in order to build an end-to-end timing infrastructure which is resilient enough to support all the end user, the end applications essentially. But once we have now this highly accurate time source deployed, we use then the optical transport to distribute this time information towards the access site, towards maybe the front hall or the middle hall. We will then eventually further relay then this timing towards the 5G radio. But not only 5G mobile operators are interested in this architecture. We also see DVB-T2 operators which are going to change the current operational model towards this because they have a mandate, and the mandate is to guarantee TV broadcasting is available at any time of the day. And they were asked by the government to make that happen, and that's why they deployed such an infrastructure. We can go further into the smart grid or the smart city kind of scenarios. And also here, we need to deliver the timing not only to the 5G antennas, but we need also to deliver the time information over maybe a private network into an industry. And that can only be guaranteed if you have a system like this in place. Otherwise, you will compromise the availability and the services you're actually offering to the customer. So I hope this has given you some clarity about time and what to do in order to make time, to have the right timing solution for your 5G network. And if not, I will be here for the rest of the day, of course, and happy to discuss any of the other aspects or questions you may have. Thank you for listening.
Thank you so much, Jörg. Much appreciated.